So hi guys, we are with the new chapter now, chemical kinetics. Chapter outline, we are going to study in this chapter rate of chemical reaction, factors influencing rate of chemical reaction, integrated rate equations, pseudo, first order reaction, temperature dependence of rate of reaction, and collision theory of reaction. Okay, so let's begin with rate of reaction. Now, children, every reaction has got reactants and products. Reactants react to form products, right? So, how much a reaction has taken place? What is the extent of reaction that you study in the chemical equilibrium chapter? On the basis of the value of equilibrium constant, you can decide the extent of reaction. Whether the reaction is towards the uh, forward reaction or towards the backward reaction, or how much of the product is formed, that all we come to know in the chapter of chemical equilibrium. Then feasibility of a reaction, whether the reaction will happen or not happen, is called the feasibility of a reaction. So this we come to know by the value of the free energy. So if there is a decrease in free energy, we say the reaction is spontaneous and the reaction can occur. Okay, so this we study in thermodynamics. Now, in this chapter, we'll be studying about rate of reaction. So basically, chemical kinetics is a branch of physical chemistry in which we study about the rate of chemical reactions and the factors affecting rate of chemical reaction. Right? So rate of reaction. Now, the reactions, if you categorize them, they are categorized into three react types: very fast reactions, very slow reactions, and moderate reactions. Okay. So when you add silver nitrate and NaCl together, what happens? Silver chloride is formed and NaNO3 is formed. So this reaction happens very fast. Or if you burn your stove, gas stove, then this reaction also happens very fast. So some reactions are rapid, while some reactions happen with the moderate speed, like the hydrolysis of sucrose, sucrose hydrolysis to give you glucose and fructose, decomposition of hydrogen peroxide decomposes to give you water and oxygen. So these reactions, they happen with the moderate speed. While so basically some reactions are very slow, that they occur with a very slow speed. They take years to complete. So for example, rusting of iron. Iron reacts with oxygen and moisture to form rust. Rust is nothing else but hydrated ferric oxide. So now, whose rate can we calculate? Can we calculate the rate of the reactions which are going very slow or very fast? No, it's not possible. We can calculate the rate of the reactions which are going with a moderate speed. Okay. So that means rate of chemical reaction is a measure of how fast the reaction can occur. So rate is expressed per unit time, and change in concentration per unit time. Like we know that speed of car is change in distance per unit time. Okay. How do you measure the speed of a car? Change in distance upon change in time gives you the speed of the car. Similarly, the rate of reaction is expressed in change in concentration per unit time. So rate of chemical reaction is nothing else but rate of change of concentration with time of different chemical species taking part in a chemical reaction. Okay. So that means rate of reaction is calculated with respect to that species. Either the rate of the species decreases or it increases. So if it is a rate of decrease in concentration of reactants, then the rate decreases, and it is also known as rate of disappearance of reactants. While the rate of increase of concentration of products is also known as rate of appearance of the products. So that's how you measure the rate of chemical reaction, on the basis of the decrease in concentration of reactants or increase in concentration of the products. For a gaseous reaction at constant temperature, the rate is expressed in the rate of change in partial pressure of the reactants or products. So concentration is directly proportional to the partial pressure of the species. Okay. Okay. Now let's see here. A is giving you B. A is a reactant which reacts to give you B, which is a product. So the rate of reaction continuously changes with time. As the reaction progresses, the rate of the reactants decrease and the rate of the product increases. So it constantly changes during time interval. So then how you measure the rate of the reaction? In that case, the rate of reaction over a definite interval of time is called as average rate of reaction, and this average rate of reaction is measured. Okay. Now, how do you measure the average rate of reaction? Let's see. Let's say at time t1, the concentration of the A reactant is A1, and at time t2, the concentration of reactant A is A2. So what is happening to from A is changing from A1 to A2. So that means there is a decrease of concentration that is happening from A2, A2, A1 to A2, and A2 has a lesser concentration value and A1 has a more value. So delta A will be negative. So to make this negative into positive, you have to put a negative sign there. So let's see how. So delta A is equal to A2 minus A1. The time duration will be what? Delta T is equal to T2 minus T1. Similarly, for the product B, what is happening? The concentration is increasing. So let's say the concentration of B initially is B1. Then as the reaction progresses, concentration of B changes to B2. So the rate of change of concentration will be what? B2 minus B1 upon delta T. So B2 minus B1 is the increase in concentration of B. So rate will be represented either is equal to minus delta A by delta T, or it is plus delta B by delta T. And the rate will be equal to minus delta A by delta T is equal to delta B by delta T. Okay. So there is a decrease in concentration of A and increase in concentration of B. Why we are putting a minus sign here with A? Because when it is a decrease, then it is negative value, and if you put a minus sign here, then negative becomes positive. So to make the negative value positive, you put a negative sign here, because rate cannot be negative, rate has to be positive, right? So that is how you find out the average rate of reaction. So here when we plot a graph between concentration of reactants and time, we see here it shows a downward trend. That means as the time increases, the concentration of the reactant decreases. So here we see at time t1 the concentration of A is A1, at time t2 the concentration of A is A2. Okay, so the average rate will be what? Delta A by delta T minus delta A by delta T, because A2 has a lesser value than A1. A2 minus A1 is negative. So to make the negative positive, negative is added. So negative delta A by delta T is the average rate of the reactants. Then average rate of the products will be what? Is measured with the increase in concentration of B. So as you plot a graph between concentration of products and time, you see the increasing trend. The concentration of the product increases with increase in time. So if the initial concentration is B1 of the products, final concentration is B2, then B2 minus B1 upon T2 minus T1 gives you the average rate of the reaction. So average rate doesn't predict the rate at a particular instant. That means from average you come to know average rate of reaction. But if you have to know the rate of reaction at a particular instant of time, you have to find out the instantaneous rate. Now change in reactant and product concentrations. So if you take a reaction, hydrogen plus iodine giving you 2Hi, and you plot a graph between concentration and time, you see there is a decrease in concentration with increase in time intervals of the reactants, and reactant, that is hydrogen here, and there is an increase in concentration of Hi with increase in time interval. So 2 moles of Hi produced for every mole of hydrogen consumed. Okay, so when you take out the rate at different time intervals, you observe here the rate of the concentration. Rate of hydrogen decreases uh, with increase in time interval. So as you move from 0 seconds to 100 seconds, the rate changes from 0.0181 to 0.0030. So there is a decrease in the rate of reactants, decrease in the concentration of reactants, and hence the decrease in the rate of the reactants. So if we look at 10-second time interval, the rate of reaction gets slower. Okay. But then later on you see the rate of reaction decreases faster. Now let's see the another reaction. Nitrogen gas plus hydrogen gas giving you ammonia gas. In this, 1 mole of nitrogen reacts with 3 moles of hydrogen to give you 2 moles of ammonia. So rate is measured with the rate of consumption of nitrogen or rate of consumption of hydrogen or rate of production of ammonia. So rate of consumption of nitrogen is equal to 1/3 rate of consumption of hydrogen and half rate of production of ammonia. So you can measure the rate either wise. So by convention, the rate of reaction is expressed as the overall rate of reaction by dividing the individual rates with the stoichiometric coefficients. So let's take one more example here. A plus B is giving you C plus DT. So the rate will be equal to what? Either we express in terms of A or B or C or D. So minus 1 by A by delta T. Either this is the way you express the rate of the reaction, or minus 1 by B delta B by delta T, or we can say plus 1 by C by delta T equals to plus 1 by delta D by delta T. So eitherwise you can express the rate of the reaction. So we can predict the rate of change of one reactant or product based on the rate of change of another. Okay, so you can predict the rate of change of one reactant or product based on rate of change of other. Okay, so we cannot predict rate based on the balance equation alone. You require to write the rate equation, then you can predict the rate of you can predict the concentration of the reactant or product with respect to the rate of change of another. So rate of chemical reaction at a given instant is called instantaneous rate of reaction. So if A is converting to B and we have to measure the rate at a given instant, let's say we have to measure the rate at 8 seconds or 10 seconds, then at that time whatever is the concentration, the change in concentration upon time will give you the instantaneous rate. Mathematically, the instantaneous rate is represented by replacing delta by small d. Okay. Now how do you find out the instantaneous rate graphically? Let's say a reaction A giving you B, A is converting to B, then the rate of the reaction can be measured. Let's see the first graph here, concentration and time graph. So for the reactants, concentration of the reactants decreases with the increase in time, and therefore a curve is obtained. And when you draw a tangent here, this tangent will give you the change in concentration upon in the given time interval. So minus dA by dt. Okay. Similarly, so by finding out minus dA by dt, you can find out the instantaneous rate. Then if you see with respect to products and plot a graph between concentration and time, then the slope shows an increase in concentration with the time interval, and therefore again the curve is obtained. And when you draw a tangent, you can find out the instantaneous rate by finding out the change in concentration at a small time interval. Okay, so dV by dt will give you the instantaneous rate for the concentration of react with respect to concentration of the products. Okay. Now instantaneous rate of reaction for the reaction H2 plus I2 giving you 2HI. Let's measure. So rate at any single point is called instantaneous rate, determined by calculating the slope of the tangent to the curve. So using hydrogen, let's say rate of change of concentration of hydrogen upon time. So the rate of change, let's say it's here at a given instant, it is 0.28. Okay, so small instant here, a tangent is drawn, and in this time interval, the change in concentration is minus 0.28, and the time interval here is 40 seconds. So in that 0.0070 moles per liter per second is the rate. Then using HI is what? Plus half delta HI by dt, delta T. So it is plus half, and for HI it is we have taken this instant here, drawn a tangent. So this is 0.5 56 molar divided by 40 seconds. So your instantaneous rate for this is 0.0070 moles per liter per second. Okay, so that's how you calculate the instantaneous rate. Now for the reaction A plus B gives you C plus D. If this is the reaction, then your average rate will be what? Minus is equal to minus 1 by A by delta T. This is equal to minus 1 by B delta B by delta T. Or it can be represented with respect to products plus increase in concentration plus 1 by C delta C by delta T. Then or is equal to plus 1 by D delta D by dt delta T. Okay, but when you are showing the instantaneous rate, then you have to show for a very small change. So minus 1 by A dA by dt is equal to minus 1 by B dB by dt plus 1 by C dC by dt or plus 1 by D dd by dt. Okay, so that's how you find out the rate of chemical reaction. For a particular reaction, you can find out the average rate. For average rate, you are using delta, and for instantaneous rate, you are using D. Clear? Okay. So nitrogen plus hydrogen giving you ammonia. If this is the reaction, then with respect to nitrogen, the rate is what? dN2 by dt. With respect to hydrogen, the rate is minus d H2 by dt, concentration of H2 by dt. With respect to ammonia, I have to find out. So plus d ammonia by dt. Now in the question, you have to see what is asked. Accordingly, you can find out the rate. But if overall rate of reaction is asked, then you can equate them is equal to minus dN2 by dt minus 1 by 3 dH2 by dt, then plus 1 by 2 d ammonia by dt. So overall rate of reaction will be given by this. Okay, so now you have to see what is asked in the question and accordingly you can calculate. Okay, what is the unit of rate of chemical reaction? So rate we are saying is rate is a change of concentration with the time interval. Delta C is change in concentration of any species. Delta T is time change corresponding to the concentration change. So unit of rate is what? Unit of delta C upon unit of delta T. Unit of delta C is what? Moles per liter, and unit of delta T is what? Second. So the unit is moles per liter per second. Or we can say moles per dm cube per second, because 1 liter is equal to 1 dm cube is equal to 10 to the power of minus 3 meter cubes. Clear? Okay. Now, for a gaseous reaction, what will be the unit? So, for the gaseous reaction at constant temperature, the rate is expressed as R instantaneous is equal to dP by dt. So, instead of dC by dt, you have dP by dt, and P is partial pressure of the component. So, the unit of the rate becomes atmosphere per second, right? So, units of concentration is moles per liter. Unit of rate of reaction is moles per liter per second. For gaseous reaction, if the rate is expressed in terms of partial pressure, that is atmospheres, the rate of change in partial pressure of the reactant or the product, the unit of rate of reaction is atmospheres per second. Clear? Okay, let's see this question. For the reaction R giving you P, the concentration of the reactant changes from 0.03 m to 0.02 m in 25 minutes. Calculate the average rate of reaction using units of time both in minutes and in seconds. So average rate is what? Minus delta R by delta T. Yeah. So minus R2 minus R1 upon T2 minus T1. R2 is how much? 0.02 m. What is R1? 0.03 m. So 0.02 minus 0.03 upon the time is what? 25 minutes. So upon 25 gives you minus 0.01 upon 25. So this is 4 into 10 to the power of minus 4 moles per liter per minute. Okay. Then you can convert it into seconds by 1 minute is equal to 60 seconds. So if you divide it accordingly, you will get 6.66 into 10 to the power of minus 6 moles per liter per second. Clear? Now second question. This is the in-text question. NCRT in-text question. The second question, in a reaction 2A gives you product. The concentration of A decreases from 0.5 moles per liter to 0.4 moles per liter in 10 minutes. Calculate the rate during this interval. Okay. So with respect to A gives you product. So my average rate will be what? Minus half delta A by delta T. So minus half will be what? A2 minus A1 upon T2 minus T1. So minus half A2 is how much? 0.4. A1 is how much? 0.5. So 0.4 minus 0.5 upon 10 minus half 0.1 upon 10. So 5 into 10 to the power of minus 3 moles per liter per minute. Is that clear? So that's how you find out the average rate of the reaction. Okay. Thank you.